Hello everyone, this is Dr. Ian. For today, let's talk about rational numbers. In mathematics, language is important, and rational numbers is also another terminology that we need to get familiar with so that it will be a lot easier to work with problems in algebra, because we know that the term rational numbers refers to any number that can be written in fraction form. So it's easy to say that when you see or hear rational in a math problem, expect a fraction that you will be seeing in your textbook or in your test paper. So when we are seeing an integer like 4, you may think that 4 is not a rational number, but we know that any whole numbers or integers can be represented in fraction form by putting a denominator of 1 to our whole number. So 4 over 1 can be changed or modified into 4 all over 1. And if we have 7, we can change it into a fraction, and 7 is equal to 7 over 1, and negative 28 is 28, or negative 28 all over 1. So these are the rational numbers. So remember, rational numbers are just a fancy way of saying fraction in algebra. So what are the types of rational numbers that we will encounter in algebra? We have reduced fractions, and reduced fractions are fractions on its simplest form. And if we have a reduced fractions like 2 over 3 or 1 over 5 or 7 over 11, we also have not reduced fractions like 4 over 6. This is not reduced fractions because 4 over 6 can be simplified into 2 over 3. And to do that, there's a different lesson that you'll be able to learn or understand or hear or see on how we perform operations on fractions on our different lesson or on different topic. But 4 over 6, by factoring, it's 2 times 2, and 6 is 2 times 3. We cancel out the 2's, so we are left with 2 over 3. And we have mixed numbers, which is a mixture of whole numbers and integers and a fraction. So we have 5 over 1/4. And mixed numbers are related to improper fractions, and improper fractions are fractions wherein the numerator is greater than the denominator, like 6 over 4, 27 over 2, 108 all over 1007. Those are improper because the top is bigger than the bottom, and we can modify these improper fractions into mixed number. And if we have improper fractions, we have integers and whole numbers that can be represented in fraction form by introducing a denominator of 1 to our whole numbers and integers. And if we know our types of rational numbers or types of fractions, now we can modify or convert our rational numbers into its decimal form. And one of the reasons why we change fractions in decimal forms is because when we are working with integers, especially on plotting points on a number line or in an xy plane, it's always easier to plot fractions when it's in decimal form. So 7 over 25 is a rational number, and there is a way on how we can convert this into its fraction form. And this one will be a little easy because fractions or rational numbers is basically converting this into decimals, and decimals are also in percent form, and percent in mathematics or in other terminology, cent means 100. So this is basically per 100. And what we need to do is to change 7 over 25 or 7 per 25 into something over 100 or per 100. And there is a way on how we can convert this into something over 100 by multiplying this by 1. But we know that 7 over 25 times 1 is just 7 over 25, which did not change the value of our fractions. But there is another way that we can represent 1 in fraction form, and that is going to be 4 over 4. And why did we use 4 over 4 in this fraction? Because we know that if we multiply the denominator by 4, it will equal to 100, and 4 over 4 is equal to 1, so by multiplying 7 and 4 together, we'll have 28 over 100, or 28 per 100, or 28%. And now that we have 28%, we can change this easily into decimal, because all we need to do is to move our decimal value 2 units to the left, so we have 0.28. So it's safe to say that 7 over 25 is equal to 0.28, or just 0.28 in decimal form by using this technique. So remember, percent is per 100, and sometimes fractions like this is easily modified by thinking of a number that will change the denominator into 100. And in this case, we're able to do that because 25 times 4 is 100, but we cannot just multiply our denominator. We also need to multiply our numerator by the same number, so that it will simply multiplying 7 over 25 by 1, or 4 over 4, and now we have 28 over 100, or 28 per 100, or 28%, or 0.28. So let's see if we can use this technique to modify or convert 4 over 10 and 7 over 50 and 7 over 40 into its percent form or decimal form using that technique. So let's start with the first one. We have 4 over 10. Can we change this into something over 100? Yes, we can, by multiplying 10 by 10, and of course, we need to multiply the numerator with 10 as well, so that we are multiplying 1 to 4 over 10 as a result. So 4 over 10, or 4 times 10 is 40, and 10 times 10 is 100. Now we have 40 per 100, or 40 per cent, or simply 40%. And since we have 40%, by changing it to decimal, we have 0.40. Also, we can change it into 0.4. So 4 over 10 is approximately equal to 0.40. And this is how we're able to convert 4 over 10 by multiplying our fractions by 10 over 10, or 40 per 100, or 40%. Now, let's see if we can use that technique to 7 over 50. Can we think of a number that we can multiply 50 with so that it will equal to 100? And yes, we can. And that is 2. 50 times 2 is 100. 7 times 2 is 14. So we have 14%, or 0.14. So 7 over 50 is approximately equal to 0.14, or 14%. And we're able to use our technique because we know that we can find an integer or a whole number to multiply 50 with so that it will equal to 100. And let's test it with 7 over 40. For 7 over 40, do you think we can multiply the denominator with an integer or a whole number that will change it into per 100? And your guess is as good as mine, so let's use a different technique on how we're going to convert 7 over 40 into its decimal form. And we're going to be using long division to be able to accomplish this task. Now, like any math problem, some questions are easy and fast to solve, and some can be a little bit tedious. And this is one example on when math problems can sometimes be really easy to work with, and sometimes can take a little while to finish, like this one. So let's start changing 7 over 40 into its decimal form, and we know that 7 over 40 is another way of division notation of 7 divided by 40. And if we have 7 divided by 40, if we use long division to find the quotient of 70 and 40, we'll have 40 outside and 7 inside. And since 40 can't go to 7 evenly, we need to introduce point 0 so that we are dividing 40 by 70. So let's start our long division process. So how many 40s do we have with 70? 1. 1 times 40 is 30. 70 minus 30 is equal to, or 70 minus, not 30, 70 minus 40, because 1 times 4 is 1 times 40 is 40. 70 minus 40 is going to be 30, and we cannot divide 40 and 30, so we need to add 0 and change it to 300. And now 40 can go to 300 how many times? 7 times. So it's important that you have mastered your multiplication table to be able to confidently work out problems like this. So multiplication table is key. 7 times 40 is going to equal to 280, and 300 minus 280 is equal to 20. 20 can go to 40, so we will introduce another 0. So we'll have 200 and 200. Now 40 can go to 200 5 times, and 5 times 40 is equal to 200. And if we subtract it, it's going to be 0, so that means we don't have any remainder. So that means 7 over 40 in decimal form is equal to 0.175. And we're able to do this using long divisions. And again, it can be a little tedious, but just like any math problem, sometimes it's easy, sometimes it can be challenging like this one. And long division, another thing that long division is teaching us is the value of patience and accuracy. So that is why we need to perform this method to be able to apply our mastery of the multiplication table. So now that our remainder is 0, we can now convert 7 over 40 into 0.175. So let's see if we can use this technique to 1 over 12. Now 1 over 12, can you think of a number that you can multiply to 12? An integer or a whole number that you can multiply to 12 so that it's equal to 100. And since we cannot think of one, let's perform long divisions and convert 1 over 12, which is 1 divided by 12, into its decimal. So now we have 12 outside and 1 inside. 12 can go to 1. So let's add another one right here. So another 0. So now we have 10. Can 12 go to 10 evenly? No, we can't. So we have 0 here. 0 times 12 is 0. And we'll have 10. And add another 0 here, and now we have 100. And now 100 can go to 12 how many times? Or 12 can go to 100 how many times? It's 8. So 8 times 12 is equal to 96. And 100 minus 96 is equal to 4. We need another 0 so that we can divide 12 by 40. And how many times 12 goes to 40? 3 times. And 3 times 12 is equal to 36. 40 minus 36 is equal to 4. And notice that we have another 40 here. So let's continue. How many times 12 goes to 40? 3 times. 3 times 12 is equal to 36. And 40 minus 36 is equal to 4. And now we're going to bring down 0 here again. And it will just be repeating. And it will be a never-ending process of having 40 as our difference. And then changing it and looking for a number to divide it with 12. So that means this particular fraction is non-terminating. And 1 over 12 is approximately equal to 0.0833333 and a long list of 3. Or we can simply change 1 over 12 into 0.08 and you stop right here and put a bar on top of 3 to denote that this is a non-terminating decimal. So this one is another case that you need to watch out for when you are converting fractions or rational numbers by hand. So let's go ahead and see if we can convert more rational numbers. And again, this particular pattern will give us 40, a repeated 40 when we are taking the difference of our long divisions. So we stop right here and convert 1 over 12 into 0.0833333, or simply 0.083 with a bar on top. So let's go ahead and change 5 over 11 into its decimal form. So just like what we did, 5 over 11 is 5 divided by 11. And of course, we'll be using the long division method for this one. 11 out, 5 in. Introduce another 0 so we can be dividing 11 by 50. So how many, or 50 by 11. So how many times 11 goes to 50? It goes to 50 4 times. 4 times 11 is 44. Subtract it. 50 minus 44 is 6. 11 can't go to 6, so we need to add another 0. How many times 11 goes to 60? 5 times. 5 times 11 is 55, and we subtract it. 60 minus 55 is 5. We can do this, so add another 0. 50, how many times 11 goes to 50? 4 times. We have 44, and we subtract it, and 50 minus 44 is 6, and we have another 0 to add, or to place it with 6 so that we'll have 60, and notice that this will turn into 5, 55, and then 4. So now we're seeing a pattern. From here, we'll add another 4, and it will be equal to, this is 5, not 4. And this will turn into a pattern just like what is happening a while ago. So in this case, the non-terminating or repeating decimal will be 4 and 5. So with this, we'll stop, and 5 over 11, we can conclude that this is approximately equal to 0.45454545, or 0.45 and a number, or a bar, not a number, but a bar on top, to signify that this is a non-terminating decimal with repeating 2 decimal values. So this is how we change 5 over 11 into 0.45 by long divisions. And once again, some fractions are easy to convert, and some fraction may take a while to finish, just like what the other 3 examples that we have shown. So in this case, 5 over 11 is 0.45 with a bar on top. And with that, our number bender challenge for the day is for you to convert 1 over 11 into its decimal form using your own pen or paper, or pencil or paper, and not using calculator or your cell phone, because again, methods or math work like this is teaching us to be patient and accurate, just like how we worked out our problem for today. So that is how we represent rational numbers into its decimal form or percent form. And by understanding this method, we're able to accomplish tasks similar to what we did today, because in mathematics, some problems are fast and easy to complete, and sometimes it will take a while for us to finish it. This is Dr. E, and I'll see you again next time.